Hi, I welcome you to this RCO channel. In this lesson, we will be discussing about the chemistry chapter 5, carbon and its compounds. So carbon atomic number, what is the atomic number of carbon is 6. So each electronic configuration will be 2, 4. So in the outermost share, it is having 4 electrons. So the valency of carbon will be the valency of carbon will be 4. So what is valency? Valency is the number of valence electrons in the outermost orbit. Valency is the number of valence electrons in the outermost orbit or share. So since it is four electrons in the outermost shell, so carbon is an tetravalent. Carbon is tetravalent. Tetra means four, valent. So four valency. So now, when we say that each atomic number is 6, so it will have 6 proton, 6 neutron in the nucleus, and 6 electron in the orbits revolving around the nucleus. Suppose this is the nucleus. So in this nucleus, there will be 6 protons and 6 neutrons, and surrounding the nucleus there is an orbit. So in the first orbit, it can have only 2 electrons. So 1, 2 electrons, it will revolve around the nucleus, these electrons. And 2, it is in the K cell. K share. It is also denoted by 1. So in the K share, 2 electrons will be revolving around the nucleus. And then another one is 4 electrons. 1, 2, 3, 4. 4 electrons will be revolving around the nucleus in the second orbit. So the second orbit is called KL. L or 2. So in this there are 2 electrons, and in the second orbit there are 4 electrons revolving around the uh, nucleus. So that is why now what is the mass of carbon? So mass is the sum of the proton and neutron in the nucleus. So sum of proton and neutron in the nucleus, if it is so how much will be the mass? So it will be 12 AMU, atomic mass unit. So we have discussed about this. Why? Let me take why carbon is so important. So important. Why carbon is so much important to us to study? It is the main element present in all living organisms. It can be animals, bacteria or microorganisms, or anything that has life. So it contains all this. So that is why this carbon is also called organogens. Organogens. What are organogens? Organogens are those substances from which life originates. Originates means starts. So we can also write starts. So life. So life will be what? Plants and animals. So organogens. So carbon is also one of the elements of organogens. So what are organogens elements practically? So organogens is a name given to any substances from which life originates. So there are basically four elements given as organogens: carbon, hydrogen, oxygen, and nitrogen. So we can also pronounce as chon. So we can remember organogens are chon. Any of the elements, carbon, hydrogen, and oxygen are called organogens. So there are substances from which life originates, from which life starts. And there another element, two elements also include. So PS. So sometimes the element phosphorus and sulfur are also included, called as organogens. So let us go to the next page. So why we are discussing about why carbon is so important. So here organogens and main elements, and then let us go to the next page. Almost almost all fuel almost all fuel uh, we we use are made up of carbon. Like what are the fuels that we use? Do you know? Wood. Wood also contains carbon, petroleum. Petroleum, it can be what? Diesel, petrol, diesel, and then what? Furnace oil, and grease, grease, and wax. So there are many. So all this fuel, almost all the fuel that we use contains the carbon, like biogas, biomass, and methane, and all these are. And if you recall it, all the food that we eat also that it contains carbon, cloth, medicines, uh, and wood or housing that we use, wood that we use for housing, and all contains carbon. So when we say about the food and this food and clothing, medicine, so especially food and clothing, we can also say about this what substances, organic organic substances, like what? Carbohydrates, carbohydrates carbohydrates, rice, maize that we eat, and then glucose, and cellulose, and what? Many more, sugar, fats, proteins, and many more. So that is why carbon is very much important to study. And plastic, if you remember, all the plastic bottles and many plus different types of plastics also contains carbon. The pencil that you are using, the paper that we are using, all this contains carbon. So that is why it is very important to study. So we will discussing about the tetravalency of carbon, isn't it? So now, why it is what is the uniqueness of carbon? What is the uniqueness of carbon? It can form it can form huge number of compounds. Many types of compounds are formed with this carbon, and then compounds. So if we say containing containing carbon is more than those compounds without without carbon. So that is why we study mainly about there are three branches of chemistry: physical chemistry, physical chemistry, and inorganic chemistry, and organic chemistry. Organic chemistry. And in this organic chemistry, we mainly study about the carbon and its derivatives. Any compounds having the organic compounds that are derived from carbon. So yeah, I have said that compounds containing carbon is more than those compounds without carbon. So with compounds containing carbon, there are many. So 400,000 compounds has been identified. So there are many compounds. So these type of compounds are produced by plants and animals, they are produced by them, and some of the compounds are also man-made, made by us human beings. So we will be studying somewhere in this chapter. So why it is? So we have said that carbon electronic configuration is 4. So tetravalent. So these 4 electrons, it cannot lose electrons also. I am writing E minus electrons also. It cannot also gain electrons to attain what stable electronic configuration of nearest noble gas. So why it cannot lose and why it cannot gain electrons? We will be discussing about what is nearest noble gas configuration stability. So you have studied about the octet rule. What is octet rule? Octet rule is the what tendency of an atom to transfer or share electrons in such a way that the outermost orbit has 8 electrons. So it is the tendency of forming a bond. It is a transfer of or sharing of electrons in such a way that the outermost orbit has 8 electrons. Suppose this is the nucleus and then this orbit. So there is an exception to the octet rule. 1 and 2 elements, hydrogen and helium, it can have only 2 electrons. So it is also called it. So for this, we will say that duplet rule. Duplet rule is the tendency of an element in which to transfer or share electrons, in which the outermost orbit has two electrons. So it will be stable. But other elements will be stable only when the outermost orbit has 8 electrons. So it will have 8 electrons. If it is not having 8 electrons in this outermost orbit, it will not be stable. So that is why they will be trying to form a bond. They will feel like going somewhere else, not stable. Oh, I am not happy and I am not stable. I need to be stable. I need some more electrons in order to become 8. So I will gain electrons and become stable. And I will lose electrons and become stable. So they will be doing all these things, this chemistry and atoms and elements will be. So that is why we were discussing about the it cannot lose and cannot gain electrons. Why it is so? We will be discussing in due time. Okay. So now occurrence. Let us say about the occurrence of. So carbon occurs at around what 0.03% of Earth's crust Earth's crust. So it has only this much of percentage, but still it is important. So in what type of forms they are present? Suppose now in free state they are present. In free state they are present in the form of diamond. You may be aware of diamond. I will not say anything about this. And graphite. The most common form of graphite that we use is what in your pencil. So coal. So these are the free form or in free state. They are present. Let me write here one. in free state. Diamond, it is the purest form of carbon. Purest form of carbon. Graphite is somewhat less pure, and this is very impure form of carbon, and it contains around 60 to 90% of carbon. 90% of carbon. So these are the things. And then in the combined state, in the combined state, in the combined state, so in what form they are present? In what form they are present? In many compounds they are present. Okay. In many compounds, we will be knowing what are the many compounds this. So in combined state, it can occur in solid in solid form also, and it can also occur in liquid also, and it can also occur in the gaseous form also. Gaseous form, gas form or liquid form. Okay. So now let us go to the solid form in combined state. Solid form of carbon uh, combined state. So what are the some of the elements that we will discuss? So lime or chalk, lime or chalk or marble. So it is the compound of what? It is a compound of what? Calcium carbonate. So why it is CaCO3? Let me give in brief. So calcium is atomic number 20. So 2, 8, arrow, 2, 8 and what? 8. So it is 18 and 2. It has a valence. It will lose electrons. So it will be 2 plus. When it lose electrons, it will be 2 plus. And the carbonate ion, it is a complex for you to understand, but you just remember that it is a 2 minus. So this 2 will go this side and this 2 will go this side, or this 2 and 2 will get cancelled, so 1 and 1, so it will be this. So what about the sodium carbonate? Sodium carbonate is this one, Na2CO3. Why it is? Sodium is atomic number 11, 2, 8, 1. So it will lose 1 electrons. So plus 1. And then this is 2 minus. So this 2 comes here. And then this 2, this 1 goes this side. So this is additional information. So another one in the combined state is what? Solid form. What? Magnetite. Magnetite. So magnetite. So magnesium carbonate. Magnesium carbonate. So why this MgCO3? It's somewhat due to this. Magnesium is what? 2a 2 electronic configuration. So there are 2 electrons in the outermost orbit. So now another one is selamine. Selamine is a what? It is a compound of zinc carbonate. Zinc carbonate. Zinc also has a 2 valency, and then this is 2 minus. So sometimes zinc is also present in zinc 3, valency 3 plus with the charge. So, but here it is 2 plus. And another one is dolomite. What is dolomite? Dolomite is the compound combination of magnesium carbonate and calcium carbonate. So these are the some of the important and common elements of carbon. In each of them, carbon is present, isn't it? So now let us go to the liquid state. Liquid state, liquid state, liquid state combined form of carbon. Combined form of carbon. So in what form they are present? You will know. What is it? Petroleum. Petroleum. So in that carbon is present. In petroleum, what are it include? Petrol, diesel, kerosene. What are more? Furnace oil that I have said, and grease also somewhat semi-liquid, and it is also present in vegetable oils. Vegetable oils. So These are the forms, some of the forms of liquid forms of carbon in the liquid combined state. Let us go to gaseous state. Gaseous form or gaseous state. And what are these? Carbon dioxide that we breathe out, carbon monoxide, and nitrogen dioxide. All this is natural gas or Mars gas. You might have heard of it, Mars gas. And then what? Coal, coal gas, and all this. So these are the some compounds of carbon in the combined state, in the solid state. Combined state, they are present in solid also, liquid also, gaseous form also. Okay. So now let us come to the covalent bond. So we will discussing about the carbon. Carbon is this electronic configuration is 2 is to 4 because atomic number is 6. 2 is to 4. So there are 4 electrons in the outermost orbit. So now what is covalent bond? You have studied ionic bond in the previous chapters of chemistry. So covalent bond is the bond formed by by let me write mutual sharing of mutual sharing of electrons. So if there are two atoms A and B, so they will share electrons. Okay, if it has one electrons and then another electrons here also, suppose this is hydrogen and this is also hydrogen, so they will share electrons and will become a duplet. So suppose this is hydrogen and then another hydrogen, they are having one electron. So this hydrogen is from this side and this hydrogen red one is from the left side. So since they are sharing electrons, so it has become a duplet and stable, and then here also it has become duplet, so it is also a stable. So like this it will be sharing of electrons will be happening. So such type of uh, bond is called bond formed by sharing of electrons are called what? Covalent bond. So covalent bond is formed by non-matters only. Okay, non-matters only. Let me go a quick give a quick information about the ionic bond. Ionic bond is formed by the transference of transfer of electrons from one atom to the other so that means matter matter will lose electrons, and non-matters non-matters will gain electrons. Suppose now sodium. What is the atomic number of sodium is 11. So 2, 8, 1. So it has only one electron in the outermost orbit. And then another one, let us write chlorine. Chlorine, what is the atomic number of chlorine? It is 17. So 2, 8, 7. So in order to become 8, it will need one more electron. So it will gain electron. So it will take the electron from this hydrogen. Suppose here I am writing with different color electrons. I am writing here 1, 2, 3, 4, 5, 6, 7. So only the outermost orbit will be participating in the bond formation. These internal electrons will not take part in bond formation. Okay. So now this sodium will lose electrons and will become 2, 8, and this one will gain one electrons and it will be 2, 8, 8, and it will be stable because it attains the octet rule, because it satisfies the octet rule of the nearest noble gas configuration, like argon type. Argon is atomic number 18. So this one will be attaining like the neon type. Neon is 10. So we will be forming like sodium chloride. Or we can also say that since sodium is losing electrons, so it will be electrons from the sodium will be towards the carbon because it is pulling electrons. You have studied in the about the what electronegativity. Chlorine is very electronegative, so it will pull electrons from the metal, this sodium. So it is losing electrons. So that is why we can say that we can also write it is plus and Cl minus. It lose one electron and gain chlorine is gaining one electron. So we can also write in this way. But it is an ionic bond. Okay, ionic bond means there will be a positive and negative charge. There will be a positive and negative charge. Okay, so this is about the ionic bond. So most ionic bond are solids. Okay, they are solids. Why they are solids? Because the bond is very strong. Very strong, and if their bond is very strong, it will have high melting point and boiling point. Okay, so since they are having a positive and negative charge, so they are also a good conductors of electricity. What are the common elements, metals that are good conductors of electricity? Silver, copper, that is being used in the household circuits and all these things. Okay, so in this ionic bond, metal lose electrons and non-metals gain electrons. So now we are discussing about the covalent bonds. Let us come back into the covalent bond. Okay, so they are formed by non-metals only. Let me write here one definition. Number two, this formed by non-metals only, and then since they are formed by mutual sharing of electrons, uh, bond is bond is weak. So if the bond is weak, that means melting point and boiling point will be what? Low, because the bond is weak, not strong. So it will be very low melting point and boiling point. If the bond is weak, what will happen? So it is very weak. It will break easily, and then what will happen? So that is why they are also intermolecular. Suppose there are hydrogen and uh, hydrogen. So these attractions will be like van der Waals forces of attraction. Okay, in intermolecular forces of attraction are weak, so they cannot attract and they cannot hold together. So that is why they will be existing in the gaseous form. Gaseous form. So most covalent compounds are gaseous in nature. So what are covalent compounds? Compounds formed by the mutual sharing of electrons. Okay, let me go to the next page. So let me give a brief of about the valency. So what is the valency? Valency is the number of valence electrons in the outermost orbit. Okay, outermost orbit or share. So so this valency is the it determines the combining capacity of elements, combining capacity of uh, uh, elements. So that means if it determine the combining capacity of elements. Uh, so that means valence electrons will be depending upon valence electrons. Valence electrons. So what are valence electrons? Again, valence electrons are the electrons present in the outermost orbit. Okay, valence electrons. So these valency or valence electrons will be determining that uh, how many bonds will be forming. Suppose now sodium is having only 281, so it has only one electron, so it will form only one. So chlorine, chlorine is what, 287, so to become 8, it needs one more, so it can form only one bond, so that is why one bond. Suppose now carbon is 2 is 4, so it can form 4 bonds. Suppose now oxygen 2 2 atomic number is 8, no, 2 6, so there are 6 electrons, so it can form 2 bonds. So now let us see one carbon, there are 4 electrons. So oxygen 1, let me write in black, 1 2 3 4 5 6. Let me write also that side, oxygen 1 2 3 4 5 6. So this will be forming bond form. So bond form. So look now, carbon has 4 electrons in the outermost orbit, so that is why it it will form 4 bonds. So that is why we can say that by knowing the valence electrons, it can form 4 bonds. So it forms 4 bonds. So it has 6 electrons. So to become 8, it needs 2 more. So each oxygen atom forms 2 bonds with other atoms. So this is about the valency in brief. Okay. Let us study about the tetravalency of carbon. Tetravalency of carbon, why it is two electronic configuration is 2 is to 4 and 4 electrons in the outermost orbit. So it can form